is, before we continue on 5.2, would you like for me to stop now, or do you want me to wait till the end of the class and work one of these problems off your worksheet? Wait till the end of class. Okay, so we are on 5.2, okay, and we had written down A, we had done A, right? We're on exercise, or example 1, sorry. We're on example 1. You're supposed to be answering, is it a polynomial function? Okay, if so, then you're supposed to answer. You're supposed to put it in standard form. Y'all remember this? Y'all got this in your notes, right? And then you had to answer these questions. A, what degree is it? Now, when I say degree, what are you supposed to be thinking? Highest exponent. Highest exponent. You're supposed to tell me its type. What is that talking about? Yeah, the name of it, okay? The name of it. And remember this, too, that one of the, well, I'll talk about it in just a sec. And then the leading coefficient, okay. And the leading coefficient is going to be the coefficient of the highest exponent. May not necessarily be the leader until what? You put it in standard form, okay? So they call it the leading coefficient because when it's in standard form, he is the leader. But it's not always given to you that way because they want to know, do you know what you're talking about? All right. So type, the one thing that I was going to tell y'all is, and I may have said it the other day, one of the big mistakes that I get on the test, because on the test I'm going to ask you some of these questions, all right? I'm going to give you a function and say, hey, put this in standard form. What degree is it? What's its type? And the one that kids can't remember is what? Quartic, okay? And here's what they go. They got the quarter thing, but they can't remember. It's just quartic, okay? And they'll call it a quadratic. Like, that's not a word. You can't just make a word up, okay? You were close, but you didn't get it, okay? So you have to say it exactly. All right, did we do B or did we just write it down? We did A and B. Okay, so let's start at C. Okay, so you're going to answer these questions for me. Here it is. F of x is equal to. Don't say it out loud. Just write your answers down. All right. You got it? Okay. So the first question, is it a polynomial function? No. Very good. No. All right. So thank you very much. I'm going to ask you this, okay? I want to say, justify your answer. What are you going to tell me? Okay, listen to me. Yeah, I don't want you to tell me that there's a negative exponent, because listen to me. What if I had written a problem like this? Is that a polynomial function? That is a polynomial function because all this is 1/7. Okay? You don't have x's raised to a negative exponent. Okay? That's exactly right. So I don't want you just to say it has a negative exponent. You have to say x is raised to a negative exponent. Okay? You have to say x is raised to a negative exponent. You could have just put x to the minus 1. That's the problem. He's the one that's causing it not to be a polynomial function. Okay, so let's go back right here and you tell me the things. What are the things that will make it not be a polynomial function?
X is on the bottom.
Okay, if you have an x in the denominator. What else? X is raised to a negative power. And y'all, these two things are the same thing, aren't they? These two things are the same thing. But if I say x is raised to a negative power, sometimes kids won't understand that really means that it can't be in the denominator. All right? One other thing. Very good. X can't be an exponent. That's an exponential and not a polynomial function. Okay? So those are the three things that you're looking for. If it has any of these three things, then you go, nope, he's not a polynomial function, so I can't tell you all this stuff. Okay? All right, here's the next one. You ready? This is the last one, and then we're going to do just a couple more problems. Pardon me. All right, you got it? What do y'all get?
No.
Very good. No, it is not a polynomial function. Why?
X can't be an exponent.
Very good. Oh, crud. I walked all the way up there. Give me some cough drops. So, no, X can't be an exponent. Okay? All right, so let's work a problem. No calculator. Okay? I don't want you to use a calculator because I'm trying to make a point. So this is example 2 in our book. It tells me to evaluate f of x equal to 2x to the 4th minus 5x to the 3rd minus 4x plus 8 when x equals 3. Okay? When x equals 3. So, what am I going to do, guys? Yeah, plug in what? 3. Yeah, so you're going to find an f of 3. That's another way to say it. Okay? So you do it really quick. Okay? So, what'd y'all get? Y'all get it right? 23. Close. Closeness just doesn't count in math. Oh, you were finished. Oh, okay. If you were on the way, I'm okay with that. All right. So, does everybody know how to do this, though, right? I mean, you're just raising 3 to the 4th power. How do you raise 3 to the 4th power really fast? Yeah, square it, square it. 3 squared is 9, 9 squared is 81. Pow, there it is. Okay? So easy. That's a lot easier, isn't it? 3 to the 3rd is 27, and then I just multiplied these. 2 times 81 is 162, 5 times 27 is 135. I don't like to subtract, so I'm not going to do it but one time. So I collected my positives, made 170, my negatives, made 147, and subtracted my 1 time. Okay? What if I could show you a faster, easier way to do this? Would you like it? Okay. No, not a calculator. Okay, I'm not talking about using a calculator. I'm talking about using your brain. All right. So now listen to me. I'm going to show it to you, and some are go like, "That's stupid," but it has a purpose, and it's other than this. Okay, it has another purpose besides this. But now, what does this mean? F of 3 is 23. What is that telling me?
When x equals 3.
Yeah, the point 323 is where? He's on that curve, people. He's on that curve. He is a solution to this equation. All right? He is a solution to this equation. If I pop this in my calculator and y equals and went to my table, that point would be in my table, wouldn't it? Because it lies on that curve. Okay? All right. So you got this on your notes. All right? And I'm going to show you. Now, this is called, now listen, I don't know why they do this, all right? But I'm going to tell you everything right now, okay? So, it's called synthetic. Now, when I say, that's not the way you spell synthetic. Sorry, I put a little extra E in there. Not a speller, never claimed to be. So when I say synthetic, what's the first word that comes to your mind?
Robot.
Fake. That's what word comes to mind. Synthetic is kind of like fake. Okay? So it's called synthetic substitution. Okay? Synthetic substitution. So it's kind of like fake substitution. Now we just did real substitution, didn't we? Yes or no? Y'all talk to me.
Yes.
Thank you. All right, now, watch this. One section over, maybe 2 sections over, they're going to quit calling it synthetic substitution and call it synthetic division. Okay? They're calling it synthetic substitution really now because it's just another way to substitute that number in and get your answer. But it's a lot faster and easier. Okay? So what is it going to do? It's going to take that equation that you just had, f of x is equal to 2x to the 4th minus 5x to the 3rd minus 4x plus 8, and when x is equal to 3, and it's going to take out all the fluff and stuff and just use the bare bones numbers, okay? Just use the numbers. All right, so there's a couple of rules that you have to abide by when you use synthetic substitution or synthetic division. They're both the same thing, okay? So, number 1, it must be in standard position. What does that mean? Standard form. Sorry, I don't know what happened to me. Standard form from greatest exponent to least, and very, very important, all powers must be represented. Okay, now what does that mean? That means all the way from the highest exponent to what? What is the lowest? Now, 0. And this is one. There's going to be one on the next worksheet, okay? And this one right here, this 0 one's going to, it messes a bunch of kids up because what happens is that everybody's got an X. And so they just write all those numbers down and they forget, hey, he doesn't have a constant. And you got to put a 0 in there, okay? So when I say all powers must be represented, if somebody's missing, what do you have to put in its place?
0.
0. And y'all listen to me. If you don't put a 0 in its place, you'll miss it, okay? You will miss it. All right. So the first thing I'm going to do, is he in standard form?
Yes.
Are all powers represented?
No.
Okay. 4, 3, oh, there's a 2 missing. So in here, I should have a 0x squared. So 4, 3, 2, 1, 0. They're all there. All right. Now look, it's synthetic division, people. Normally when we divide, we make a big house, right? We're going to make a porch. Oh, it's like we're retiring, okay? And we're going to sit on the porch. One day, it's going to happen for me, okay? So, and all you're going to do is, on this porch, leave you a line right here to write, but one line above that. You're just going to write the numbers, the coefficients, and their signs, okay? So this is going to be a 2. What's next? -5. What's next? -0. Oh, what's next?
-4.
Perfect. And then 8. Okay? The number that goes out front is this number right here. 3. Okay? Now listen. This is a little weird, all right? But it's not hard. Just weird, but not hard. So the first thing that you always do is you just bring down the first number, 2. Okay? And then you multiply. What's 2 times 3? And then you write it here. And then you add. What's -5 and 6? 1. So, put a 1 down there. And then you're going to keep doing that same process over and over and over.
3 times 1 is 3.
Yeah. 3 times 1 is 3. And then what are you going to do? Add it. 0 and 3 make 3. And then what are you going to do? Y'all, you just keep doing the same thing. We're not going to change what we're doing. So then we multiply. What's 3 times 3? 9. What's -4 and 9? And then we multiply. What's 5 times 3? What's 8 and 15?
23.
Look at there. There's the answer. Okay, that's pretty cool, isn't it? That is pretty cool. Did you have any big, huge numbers?
No.
No. It can be really fast. Very, very fast. Okay? Because, you know, you're not dealing with a whole bunch of big numbers. So, look, this is a big thing right here, guys. You have to remember that you have to insert zeros if you have a power that's missing. If you don't insert that 0, y'all, you will not get the correct answer. Okay? We had to have that 0 to get the correct answer. All right, you want to work one problem, and then we're really finished. Okay? So here's your problem. F of x is equal to -3x to the third minus 2x plus 5, and I want you to find f of -3. But I want you to use synthetic substitution. Okay? So I'm telling you how to do it. Do what? Yeah, that's what we just did. All right, y'all got the answer?
I got -82.
Uh-oh, let's see what's going on. All right, so here we go. First thing, y'all listen to me. This is what I do every time. I go, all right, 3, 2, uh-oh, you got somebody missing. If you didn't put a 0 in, your answer's wrong. So, 3, 2, 1, 0. So, negative 3, 0, negative 2, and 5. What? Wherever somebody's missing. There's a 3. Is there an x squared? So, if you put this in standard, if you collected, if you represented all your exponents, there's a 3, there's a 2, there's a 1, and there's a 0. Okay? So whoever's missing, see, 3, 2, 1, 0. You have to put that 0 in there. All right. Now, tell me what to do. How do I start? Bring the first one down. Guys, they're giving you the answer on the first one. They go, hey, guys, start here. Negative 3. Okay? And then you multiply, add. Multiply, add. Multiply, add. So, what's negative 3 times negative 3? So, it goes here, and then you add, and then you multiply. What's 9 times negative 3? Negative 27. What's negative 27 and negative 2? And then you multiply. What's negative times negative is going to be a positive. What's 3 times 9? Carry your, 3 times 9 is what? 27. Carry your 2. What's 3 times 2? Plus 2 is 8. And what's 87 and 5? Okay? So evaluate it. Y'all tell me what the point is. Negative 392. Or, what would f of negative 3 be equal to? Alright. So, either way is a good way. Alright, there's my answer. Anybody got a question? Okay, so there's some other stuff in 2, and we're going to stop right here, though. Okay? Take your worksheets out. 15. I'm going to do 13 and 15. Okay? Those are the 2 that I'm going to do, because I think I can use those 2 to show you what I would like for you to do that will make it best for you. So here's 13.
And on number 26, it's not there. Like, I don't even know what the same is.
Oh, I'll look on my sheet and I'll write it up there. Thank you. It's one of those synthetic substitutions, so it's not too bad. Okay. Oh, okay. I'm probably going to make you do synthetic. I may change those directions. All right? Just because I think that's what you need to practice on. All right. So here we go right here. Now, y'all listen to me. Remember the other day when I said the first thing I would do is try to make exponents negative? Negative exponents positive and all that kind of stuff. Add one step above that. Make this one the very first step, okay? I would multiply across. Before I did any of that, I would multiply across. The second thing I would do would be get rid of the negative exponent. And then the last thing I would do would be to reduce it. Okay? This is the order that I would do it in. Alright? So the first thing I'm going to do is I'm going to multiply across. And the reason that I'm going to do this first is because sometimes my negative exponents will disappear. Alright? Or sometimes I'll consolidate them and they won't be as big. Alright? So on the top, y'all, this is a 1 right here. What's 1 times 2?
2.
What's x to the second times x to the 4? X to the 6. Boy, this thing's not even. This is what I go through first period. This is why I never record first period. It disconnects all the time. Okay, so x to the 6. 2x to the 6. And then you just have a y to the third, so you just have to write him down. On the bottom, what do you have? Okay, so now, do I have any negative exponents?
No.
No. So let's reduce it. What's the first thing you see? Just like that. Y to the third. Man, isn't it funny the 2's they're not the first thing we see because we're so worried about those exponents over there that that's the first thing we see. What else do you see? All right. What's your answer? Okay. Was that hard? Okay. That wasn't hard. Did you do it like this? Yeah? Okay. Good deal. All right, let's look at, now y'all look, that's not the only way you could do it, okay? You could have cross-canceled here, but I find kids make more mistakes doing stuff like that than they do if they just multiply it all out, get rid of the negatives, and then reduce it, okay? All right, so here's 15. 15 is c to the fourth raised to the third over 4 times 12d to the minus 6 over... I know, I just, my pen. Over, open parentheses, 15 c d to the negative first. Okay, so the first thing I'm going to do, y'all, I cannot multiply across right now, can I? Yeah, you have to raise to powers first, okay? You've got to raise to the powers. So, powers to powers, remember this, positive mental attitude during school. Powers to powers, you step down and multiply. When you multiply, you step down and add. When you divide, you subtract. So, powers to powers, what are you going to do? Multiply. C to the fourth raised to the third is c to the perfect. Over 4 times 12d to the minus 6 over. All of this raised to the negative 1 power is going to do what to it? Y'all, it's just putting it on the top. That's all it's going to do. And then it's raised to a 1 power. Do I need the parentheses? People don't put parentheses in there if you don't need them. They just make things look more difficult. All right? Just put a little time sign right there. Okay? Don't put a parentheses around it. Once you can get rid of the parentheses, get rid of the parentheses. Okay? So, now what's left on the bottom? A 1. You don't have to write it if you don't want to, but if you like something to be there because you're like going, that looks really stupid, then you could write a 1 right there. Dadgummit. All right. Now we're going to multiply across. Okay? So, 12. See the only number I got. C to the 12 times, yeah, y'all look. There's those 1s. Okay? So, what is C to the 12th times C to the first? Why didn't you multiply 16? Oh, I didn't see the 16. 12 times 16. I should have. What is 12 times 16? Now, what might I, y'all, I'm just going to be real honest with you. I probably would have done this. Why? Yeah, it's just a big number. I would have said, boom, 180. No, I don't like him. So I probably would have, you see, I mean, these are my general directions, but if I need to kind of make it different, I can make it different. It's not a big deal. It's not written in stone. So now it's 45. That's a whole lot nicer than 180. D to the minus 6 times D to the 1. No. Negative 5. Very good. Over what? Yeah. It's not over nothing. Alright? So what do I have to do now? Put D to the negative 5 on the bottom. So I got 45 D to the 13th over D to the positive 5. Now, can I do anything else? Can I reduce it? No. That's it, people. That's my answer. Alright? Anybody got a question?
So you always have to, like, simplify and then
Well, I mean, you don't have to. You could have done it any time. You know, the order of those things don't really matter. You can do them in any order that you want to. I think what's best is to find an order and stick with it. Because when you don't do that, then that tends to lead you to skipping steps. Okay? So find an order that you like and then stick with that order. Even though you can kind of, like I cheated on the order just then. Alright? So, Dylan. Do what now? All right. So we're going to. Oh, I'll write the other one on the board, and